to see if it's streaming. I think I'm gonna stay here for 2 hours and then I'm gonna stop streaming and then come back later. Probably. And I'm gonna continue to do the build space stuff. I think I'm gonna I'll put for 1.5 hours and then I'll see if I'm gonna stay longer now. And I'm probably gonna stop and come back after. I just moved all the files and changed the name, so I'm gonna have to refactor the imports, I think. And we didn't do much since yesterday. I just copied some of the code. And I'm gonna try to change gradually this stuff from VGS to work with the stuff that I have here. From what I was seeing, I think that the create scene is more similar to the canvas. It's both the canvas and canvas renderer. So there are functions here that are on the other files. Like, it looks like on VGS this file is split into the two classes. So I think what I'm gonna do is separate the functions. The main thing that I have to understand is what are the differences between the WebGL and the canvas, I think. And the rest I can just copy, because the only thing that I'm gonna have to do differently is to add the WebGL functionality. And the events as well. Oh, also, I've seen the recording of the stuff yesterday. Like they did not sure how to say it. I think it's a workshop or pretty much a live stream on Twitch, and Farza explained like what is gonna be he pretty much he said that you have to create a prototype, or yeah, a prototype of the stuff that you're doing by Sunday. So I kind of like, for my thing here, I don't like this very much, because now, like, after watching that, like I'm not really sure. I was thinking whether or not I should just do the easy version now before I change everything on the, because this is the main problem. Like, I already kind of have a prototype that I can do with the stuff that I have, which is just to create the simple graph, like the static graph, but then I still have to change some things there, I think, so that, like, maybe I should add a button that when you click the button, it's going to trigger the function on the API, and then provide like the simple visualization of the function that I have there, the recursive function. And then I can put the, like, in a simple, very simple way, like actually put the text of the function on the front end to, so like it displays the function and the canvas on the side. But the problem with this is that still gonna take like some work to do that, and then if I do that, then like I can't work on this stuff, this transition of the network now. So this is the kind of the problem, because ideally I would be able to transition the network first, but then the issue is that, like, I don't know how long it's gonna take for me to, because it's very complicated to translate everything here, because I have to understand how everything works and what are the differences between a normal 2D context of the canvas and the WebGL context, so I can adapt all the library, like the VGS library, to use WebGL. So, and then only after that I was thinking about doing like a simple version. But if this takes too long, then I might have to go and do the simple, like, but and then it's gonna be annoying, because then I'm gonna have to spend a lot of time doing like some work that I know that I'm not gonna use later, because it's just gonna, like, I understand why they do it like that, but the thing for my case here is like more, is not very efficient, I think, to do it like this. But it might be, yeah, I don't know. I think it's hard for their side, because obviously there's so many projects, so it's hard to come up with heuristics that are gonna work. And this is the problem, is like, the reason why they're doing this, and I agree, is because a lot of the times, and for myself as well, people have this tendency of rationalizing and not doing. Like, so they like keep building forever, and they don't actually like put the ideas out there and then iterate over like what they can do. So it's much better to just put something and then just iterate based on what's actually happening, based on the actual feedback that you get. So like doing things like this forces people to like get off localhost as fast as possible. So I understand that, and I agree with that type of thinking, but the problem is that it lacks nuance, because, and the reason why it lacks nuance is because it's very hard to come up with heuristics. So like, for some things, it's actually not that good to have this type of thinking. And I think like rockets, for example, are one of those things, and then probably like artificial intelligence or anything that has like a greater level of risk, or that is too complicated. It's probably like you need to have more nuance to be able to know like the pace at which you ship things. I think it's very dependent on what you're doing, I think. But for nights and weekends, I think it makes sense, because it's the whole point of the thing. You have 6 weeks, so yeah, I don't know. But I think maybe for future, the thing is that it's very challenging from their point of view, because how are you gonna come up with heuristics? Like, you're gonna either have to limit the space of what ideas you accept people to do, because they have only 6 weeks, like, but I think that like you can have ideas that you're gonna take longer than 6 weeks, because then you can be a part of multiple nights and weekends and then like iterate. I think that's like a cool idea as well. But then they would have to come up with heuristics like to be able to change these deadlines based on what project you have and what you're trying to do, and then it would get like extremely complicated very fast. So it's a very challenging thing. But for my situation here, like, it's kind of annoying because I don't know what to do really. Because if I start off like, let's say I ship the thing with the other version, then it would be like building on top of something that is not really, that doesn't have a strong foundation, let's say. Because then the easier path would be to continue building on top of the simple version. Because the idea of having the prototype is that you put like the minimal version of what you're doing out there. But the issue is that you need like to start with the correct foundation. That's the problem. Because if I put something that is the minimal version that I'm doing but is not aligned with the whole system in the way that I want the system to evolve, then it's kind of pointless, because then I have to redo all the work to change to the system that I'm actually going to use. But if I try to do it like the minimal version with the system that I want to use, then it might be too hard to get it done by Sunday. And I have no idea. This is one of the challenges of like things like this, is that I have no idea how hard it's gonna be, because you might encounter some roadblock. Like I don't know, I never deployed with Svelte, and I never deployed something with Flask. Also, I'm not really sure if I should use Flask or Django. That's the other thing that I'm thinking about, because if this grows to be a big application, then doing it with Flask might be a mistake. But I think that I'm just gonna do it the way that I'm doing now, because I can easily change in the future, I think, because it's like decoupled the front end from the back end, so I can have like in the future multiple versions of APIs. And also I probably can expand to other languages as well, so use other backends from other languages to visualize, like Rust. Yeah, but if it takes too long to change this or to make it work, like the minimum amount to make it work, make the graph work with VJS, then what I'm gonna have to do is just go back to the way that I was doing before, and then just do the simplest thing that I can and deploy that. And then once I deploy, then I'll go back to trying to change everything. I'm trying to decide here, like, what are gonna be the files. This is the issue, is that, like, I think the main priority that I should have now is to try to understand more how WebGL works, because I think I get it, like, I get from the concept point of view, but the thing that I don't understand really well is the coordinates, how it's gonna work. Like, what's the difference between when you do coordinates with WebGL and when you do it like with the normal context. Because from the programs I seen, the only thing you have to pass is like you pass fragments and you pass shaders, I think. But the thing that I didn't understand is that there's something about the coordinates going from 0 to 1 and is like a square on the WebGL. But then how does that relate to the global coordinates of the canvas? And pretty much clarify more what's the difference between the normal context and the WebGL context. So I can know like how to change this file here, so I can like split these functions or add these functions to the classes that I have there. Because obviously I can just copy everything and then it's going to be exactly the same as Vue.js, and I know that it's going to work because I tested before. Like if just using Vue.js like out of the box, and obviously it's going to work, but then it's not what I want to do. So because I want to incorporate this stuff there. So the thing that I have to change is the context. But then this file, it seems like it is combining both the canvas renderer class, this one, and the canvas class. So I'm not really sure how to split this one. I need to know what functions I should change on the Vue.js stuff so that the thing that I have there, it works. The other thing I can try, maybe that's the smarter approach, is to just change the context here to use WebGL and then see if it's gonna work or not. And then I can debug the mistakes that I got. I know that, yeah, here there's gonna be some function that creates the context. I think it's get context or something like that. Did I put the timer? So this function here, but I want to see where is the function that creates the context. I think maybe it's in the beginning on the constructor. I think actually this is probably the smartest idea or way. Just copy everything and then change the context. And then see, like, there's probably gonna be some problems or a lot of problems in the calculations. Then see how to incorporate the other functions into this stuff here. That I don't understand really well, I need to understand more, like from the fundamental perspective, let's say. Like what is the main difference between the normal context or normal context and WebGL context? I'm gonna copy these files and slowly change them. So I think I'm gonna put all these functions, because these are obviously methods from the WebGL. So I'm gonna put all of these methods there. And probably gonna put this stuff on the... This is the thing, if I put it on the constructor, I have to see if the other one has it on the constructor. Actually... Oh, canvas get context. No, this is from the API. So, describes. I don't understand why it's giving me an error though. Okay, now as well. No, but it's still not working here. Because I'm missing the thing. This is weird. No, it's because it's here. Didn't see that. So the main things that I think I'm gonna have to change are the view. This one uses the view matrix, which uses the GL matrix API to make a bunch of calculations for the world view, and I don't understand really well how that works. And then I'm gonna have to change as well the components, because the one that I was using uses this point collection. And this stuff here, but mainly point collection and line collection to create the program that's gonna be used in WebGL. And I'm gonna have to change this so that it works with the stuff that I have here. Also have to understand the colors, because later on we're probably gonna have to give the ability on the website to change the colors based on like whatever the person thinks is gonna be more useful So for example, in the thing of recursion that I was doing, I decided to create 3 colors because that's allowed me to understand like the levels of the recursion. I think that's the great thing about visualizing the design and the connection with graphs, is that you can add extra dimensions to the stuff that you're doing that make it a lot easier and more intuitive to understand, like how everything is connected. And there's a bunch of, I think that's like, this is what's concerning me as well, because there's so many things that I have to work on, and this is just the beginning. It's already really hard, so I'm not sure if I'm gonna be able to, like how much I'm gonna be able to achieve in 6 weeks. Because obviously this is all new to me as well, the WebGL stuff. I have the wrong structure, I think. No, maybe it's correct. No, I think yeah, this should be here. The other thing that I was thinking about is I'm gonna have to add functions to, I'm gonna have to see if it's possible, like, not if it's possible, but how can I add functions or change the library so that I can have live data? Because I think that the way that this is structured, maybe it's just, like, it works just if you pass all the data in the beginning But I think that there might be a way to like add some function through the prototype that allows you to update the network based on the... Maybe I can add some event and then I can change the rendering, or add like functionality to add the nodes in the correct place. And obviously, like, I'm gonna have to change so that it works, like, because I wanna add different animations as well, if possible, depending on how hard it is. Like, that's the idea that I had for a very long time, since the beginning. Like, the first time that I did this visualization with Vue.js is to be able to see, like, change the color of the nodes and the edges as the script executes, like to see the path of the execution in real time in the graph. I think that would be really interesting. So let me see if there are, like, what other functions exist here that I can add. Let's see the constructor first. Yeah, the problem is here there's nothing on the constructor that initializes the canvas. Maybe it's on the event listeners. But I'm thinking where should I put these functions here? And first, I think I'm gonna have to search them on the... Probably ask ChatGPT. I think these two are probably not necessary to put. And I think that's another difference, is that on here, it seems like the way that it works is on blocks, where you create these blocks of elements on the scene. So the scene root is an element that is a block, and then inside of the scene root, you append the children, which are other elements, which are the nodes and the edges, I think. So I think that's another part that is fundamentally different from the normal canvas. And this is just like the container, I think. If you pass a container to the options, it puts the canvas inside. Probably. So I don't think I'm gonna put this there. And here, that's another fundamental difference. That's the thing that I'm not 100% sure. It's because this view matrix might be different than the view class on Vue.js. And I don't understand. I think that this is like the camera state, let's say, but I'm not 100% sure. Yeah, where the camera is looking, orientation. So Like it's tricky to know what is the difference between this one and the normal canvas. Oh, this one and the view class on VJS. And this one is inside of this one. So that's another fundamental difference in the design, because on the other one they are on the same level. So I'm not really sure like what I should do, because it might be different because this one uses WebGL and the other one doesn't, but it may also be different because it's just a different design that they chose. So let me see. Like maybe I should comment everything out, and then the problem is, how do I test if the thing that I have here is gonna work or not? I guess I have to keep looking on the canvas to see if I understand how everything works there, because I didn't look at the event listeners yet. But the problem is that I think that only with one class is not gonna allow me to see if it works or not. Like maybe I can like create some test function or something like that that allows me to see if it's working. Yeah, so pretty intuitive. Only difference between once and on is that once only runs once. I think I'm gonna ask ChatGPT what is the point, what is the purpose of translation? Because I don't understand really well. I think I'm confusing translation with rotation. Yeah, there's nothing here on the initialization, but I know that here is gonna call the create after, so it's probably on the create function. This is stuff that I don't understand really well. What is a perspective and projection? How is this related to the other thing? Yeah, but I think this set size is gonna be similar to this one. Update canvas size. I think these functions are more related to the camera control file that it has here. So I'm trying to think what are functions are more similar to each other, so I can see like what are the differences and try to change the functions from the VGS to work with this thing here. But I think these functions are not very similar. I think that this camera controller here is this thing here. This probably has the functions there. Maybe set view box is similar to this one. Set camera state. So it keeps the state of the view here. So I guess that it is similar there. So it would be like this view here, which is the view matrix. Yeah. So instead of putting view here, I should put view matrix. That's the difference. So this is not the class, it's just the view here. So I think I'm starting to understand. So the view inside of the body is like the state of where the canvas is. So if you scale down or up, you have to do calculations to change this number. And if you move the position of the camera, you have to change like the state of the canvas should be to represent that. So I think on this one I should change probably, but I want to see. Yeah, let me see what are the differences, because this is a class and the other one. So the main difference is probably that this has 3 axes and it uses the gel matrix thing. This is like a lot more complicated. So it either initializes with view. So I need to understand better how. I think this is a matrix of 4x4 matrix. That's what it does. But maybe I should ask ChatGPT. And I don't know why you invert here. Okay, it's the identity matrix. Yeah, so destination is the resulting, which is this one. So it takes the matrix and inverts to this one. But why invert? Maybe should have given more context, but I think that it doesn't change because there's no explanation here. Maybe I should say that this is the view matrix. Yeah, but this clarifies a lot one of the points of confusion that I had, which is that I wasn't sure if this view matrix would be the class view there or something else. But I think now I get it's just a file because it's more complicated than normal canvas. So the question is, should I put the functions in this file? Like, so on this one, there are these functions here that are gonna change this view based on this resizing. So what I have to do is like obviously adapt the view that I have there to this one. But then should I create functions inside of the view file and call these functions here? Or should I make it like a separate thing? Like just do the view, I think I should create the functions inside of the view file. It's probably better. Because then I'm gonna have, if I don't do that, I'm gonna have to do a bunch of functions. I'm gonna have to repeat myself. So I would just add I'll add these values here to this view matrix, and then I'll put the view there. Maybe I don't have to add, I just need to change the... I have to understand more how it works. Yeah, this is what I'm thinking. Is like doesn't make a lot of sense. I'm suspicious of the code because I don't agree with the way that he did the stuff of the code that I refactored in the layout. Like, it's just a different type of thinking, I think. Like, the way that he thinks is different than the way that I think about stuff. But it's not like just say that I'm correct or he's incorrect. It's just I don't know which one is the... Because I don't understand how this stuff works as well. But I'm definitely suspicious of this stuff because it doesn't make a lot of sense in my mind. Like, why invert an identity matrix to get the camera world from the view matrix? I'm trying to understand like what could have been his reasoning for doing that stuff. Because maybe there are other things that I don't understand, that like other functions, and that makes sense on that context. I guess I need to study more how to... Like, I need to understand better how WebGL works. Like, to clarify the positioning of everything in my mind and the setup that you have to do. Because I think I can start from... Maybe not scratch, but like remove the stuff that he did. And then it's probably better that way, because then it's gonna be less confusing than like trying to understand what he did, because I don't know. Like, but the issue is that there's a lot of stuff here that might be useful, and I don't wanna have to redo that again. Probably what I'm gonna do is split the code in this file into the other classes, and then once I have all the functions split to adapt to the VJS project, I will delete this file. And I think I'm gonna try to do that for all of the other files as well. So, like, as I study the VJS stuff, I looked through the parts of the code that are similar on the stuff that I have, and that are probably gonna be the differences between the normal context and WebGL. And then I try to incorporate these functions into this project. And then as I incorporate them, I remove them from the other, and until I have like everything done. The biggest challenge is that I don't know like a good way to test if the stuff that I'm doing works, because it might be necessary to have everything to display the visualization. That's the biggest problem. Because then, like, let's say I translate everything and then I test and there's a bunch of things wrong. It's going to be very hard to know what part of the code is wrong. And that's why I'm trying to understand how the stuff actually works. I need to get a better understanding of how WebGL works in my mind, so I can understand like what is the point of doing everything that he did there to create the view on the canvas, and how that's going to be different from the stuff that I have on VJS. That way it's going to be a lot easier to know what could potentially be wrong. Let me see here. So get camera state. Yeah, I need to understand. I think as soon as I understand how... The problem is that I don't know from these names really well how to visualize in my mind what the calculations are doing. Like if they're changing the position of the canvas, or if they're changing the position of the elements in the canvas. Like that kind of stuff, and the coordinates and how does work. I think I understand, but I'm not 100% sure. And then I need to also understand in my mind like what is the whole process that is happening on WebGL to get the positions, and also to update the shaders and the program. And then as I read this stuff here, then the more I understand, the easier it's going to be to know what parts of the both projects are connected or doing the same thing. The problem is that I don't understand the pieces really well, so it's hard to know what is the purpose of each thing because I don't understand it really well. Okay, so it creates these functions. I think I'm starting to get it. So what would be the camera state? I think it would be the other file that I have there. Would be the create map controls maybe. And then the view is the thing that is updated through this thing. Yeah, the view is kind of like a snapshot of the thing. And then the camera is the thing that controls the snapshot. So the camera controller would be analogous to the stuff that is happening there on the other. But here, up camera position. So maybe set view box is the same as set. Yeah, I think that makes sense. Set camera state is the same as set view box there. should be the same. So I need to know what are the differences between this one and the other one. What is a high pot? Camera position. So camera state is probably the same as the view here, which is the same view from the thing, and here is probably gonna be the same as well. Click this by mistake. Where's the camera states? So this is different than the other one. So on this one, it is entangling the view class with the camera position, and on this one is not. It's creating a different object. So in the beginning, none of the conditions are going to be true because there isn't anything there. Maybe it sets this up on the other one, in this file. No. Yeah, this is very weird. It's just an object that doesn't have anything. And then, oh, here. So maybe here is where it initializes the values here. Yeah. So initializes on the get camera states. And it's just the height and width of the canvas divided by the pixel ratio. And scale is the scale of the view. Yeah, but it's slightly different. Let me think. Here is different because I'm not. No, this I'm getting the view from the view matrix. So this would be like the class that I'm looking at there. It's similar, but the variables are different. Position. If it's view dot position. And so on the other one, it is attaching the position to the view class, view matrix class. And on this one is creating the position outside the camera position on this class. And I think VGS makes more sense, I think. Because you don't want the position of the camera to be attached to the view, I think, but maybe you do. Then it updates the view here. So maybe I should add a comment here to remember that this function is similar to the other one. To remember that this one is similar to the set camera state. So I'm trying to see what kinds of things are similar and what is different here in the way that it's calculating. I'm mainly trying to understand the relationship between the view and the camera state on this one. I think this one seems to be more coupled, and the other one is like separate because it creates another object here to control the camera state. and some of these values are not related to the view, but on the other one, the values are the same as the view, the values in the view. But it might be more similar than I'm thinking now, because it's just making other values equal to the values in the view here to calculate the position. So it's pretty much like, it's very similar, but the way that it does it there is by creating a new object here. This will be camera state, and then when it gets the camera, it initializes the value. But some of the values don't have anything to do with the view. But in this one, they do. So, like here, previous height and width are just related to the canvas, and the scale is related to the view, and the other one doesn't have a scale on the view class, view box, or view matrix class. And the position here is just related to the canvas as well, but here is related to the view. So I'm trying to understand, like, if there's any fundamental reason for that is involved. I'm trying to think about questions so I can ask ChatGPT, so I can understand the difference, the fundamental difference between WebGL and Canvas, like from first principles. So I know if I can decouple this from the view, like do more similar to VGS and just make this like based on the canvas instead of making based on the view thing. But it might be, which is this file here, but it might be different because this one, like because you have to do more calculations, it's better to put this stuff on the inside of this file to do the calculations of the positions. And then it would make more sense to do differently than VGS does, where I just put the calculations, like I make these calculations here inside of the view matrix, and then I just make it equal to, I think that makes sense. And it's probably the reason why he did it like this, because view position is going to be more complicated here, I think. And because this class has more stuff, it makes more sense to separate them. And then instead of updating the canvas, you update the view. Instead of updating the camera state based on the canvas, you update it based on the view, because the view has the calculation for the position of the canvas. I'm not 100% sure if that's the case or not. Yeah, so it's probably, I'm probably correct here, I think. So the view matrix is like the camera state. Alright, I'll be right back. Almost time. So I think I'm gonna take a break. I think I'm gonna stay for more. I'm gonna take a 10-minute break and then stay for more 1 hour. Or 1 hour and a half. Something like that. But I think what I can do as well, I can like give these two functions to ChatGPT and then see if it can explain to me what are the fundamental differences. But I'm mainly trying to think about now if I can, like, if it is better to try to do it more similar to the way that it is here, or if I should stay with the way that it is on the other project. Because I think that the reason why the other one is more coupled is because it's more complicated. So you need to put more functions inside of the view matrix, and that's the reason why he made the camera state equal to the thing instead of creating a new object and then making it equal to the canvas. So I need to see, like, I need to understand what is the difference between the positions here. How do you track the position? Why are you tracking the position with this vector here on this one? Yeah, this vector. And why do you have center and orientation here? Then once I understand this, then I can think about how I'm gonna make it so that it is like similar to the one that they have here. And this function is converting the DOM coordinates to the canvas coordinates. I remember seeing this yesterday. So ideally I would just copy, I already have this stuff I think on the other projects. And I would just change whatever functions or whatever points are necessary to change in order to make it work with the other one. So I think for now it makes sense to make this equal to the view matrix. Let me see how it does here. I changed the place that it is, so instead of components. Here. And then maybe I should put the same methods. Let me see. So orientation stuff. So I should put scale here. The only thing that I don't know is it should probably be a vector of 3, size 3, because it's 3-dimensional. And here, but I'm not sure if it should be a vector or a matrix. I think maybe it makes more sense to be a matrix, but I don't know because these ones are vectors, so I need to understand more. The one that I don't understand is this one. The VGS one is easy to understand just by reading the code there. Hey, scientific and animal. What's up, man? So why is it wrong? Yes, because of the time. Let's put on the bottom. I think I'm gonna take the break now. Just gonna think a little bit more. I think what I have to do now is understand more how this works. How the... like, why create these variables here and whether the scale should be a vector or a matrix. Based on the other ones, I think it should be a vector, but like what makes more sense intuitive is just obviously that it is a matrix, because I think about the view as being the I square. So I don't understand really well. It might be, these ones might be a vector because it's just the axis. So I think that this scale might make more sense, should be a matrix. But I'm not really sure. Current view center. So this would be the center here. Distance from center. Yeah, the issue would be what would be the z here? And how is the... so I have to figure out which one is the... I think it makes more sense, should be the third element here of the position. Or of the center. Let's see how it's changing. I have the axis here. This is what it's tough, is because I don't understand really well, so it's difficult for me to visualize what's going on. What are these supposed to be, because of the whole thing that is confusing to me about the WebGL being from 0 to 1, is being a square, and how that relates to the coordinates of the canvas. So I need to see if there's methods are being used here. Which methods are being used? So use the position, camera world. So it is a vector because each element is gonna determine the coordinates, I think, for the position and the center. And the camera world is a matrix because it's all the combination of the vectors. So it calls here the update. Let's see if he uses the other ones. So it's accepting the canvas rectangle and then updating the position based on that, the coordinates. So left and right. So the one is the X direction, the Y, and then the third is the Z. It's what makes more sense intuitively. Just getting half of the distance from top to bottom and from left to right, and getting the max. Trying to understand why this thing here. It's like getting half and half and then getting the one that is the highest. And getting the tangent of that. Or that divided by the tangent. And I don't understand what this is. This FOV here. so update. Yeah, it's only calling the update. So in this situation, the other ones are not used. These ones. But I think here, these functions are useful. Distance, like these are the functions that I'm gonna call there, I think. I'm gonna call here. And then I just pass the distance here. I'm not sure if it is useful or not, because I still have to do the same calculation. Oh no, it's here. So it is useful. So we just pass the distance, which would be this thing here. Yeah, so instead of doing this calculation, we'll just call the methods from the class and pass this distance. Hmm. There's translation and scale. It's a lot more complicated. Like what I have there on the other one is an object that has the translate and the scale. But here I have to do with the position here, I think, instead. So the position is probably the... No, it isn't the... the position contains the X, Y, and Z. The orientation... What is the orientation? But instead of doing these calculations here, I'm gonna have to change this function so that it changes the position there. Also, I have to think about how to calculate the scale on the thing. I think I'm gonna stop for 10 minutes and I'm gonna remove the camera. Then I'm gonna continue probably for 1 hour. Or 1 hour and a half, and then I'll stop. And then I'll come back again. Actually, I'm gonna put the thing here. I'll be right back. I'm eating something, so I actually think I'm gonna watch some videos about WebGL while I eat, and then after I'm done, I'll continue to study this stuff. Or try to convert the thing, VGS.
For this first WebGL video,
Yeah, I think a good idea is also to use ChatGPT to convert everything, like one by one. I think I'm gonna start by trying to convert these functions here. It's probably the best place to start, and what I'm gonna do is just convert everything to use the view matrix instead of doing these calculations here, or yeah, change all the way that these calculations work to use the view matrix class, and try to understand how the differences are. What I'm concerned about is the thing that I might change now and I can't test it, so I'll only be able to test later. But maybe I can try to do like a small test because I don't need all the functionality. I can just see if it's gonna render anything. Yeah, but I think I need the other class to render, because this is just gonna create the canvas. Yeah, I'm gonna watch the videos then continue to do this.
we're going to create the simplest possible WebGL2 program we can. It'll be so simple, you'll wonder what the point is, but I promise it will be worth it. Throughout the series, we're going to return again and again to the code that we write here today. It'll be the foundation and jumping off point of every video that's to come. So the most minimal WebGL program is built from three things: a canvas, a WebGL rendering context, usually named GL, and a program linking to compiled shaders. Here's our HTML page. It already has a canvas in it. I've wrapped it in a thin gray border, which you can see here. The script that we're linking to is a TypeScript file, but don't worry, this is not a TypeScript series. It's just that my IDE is better set up for TypeScript than for JavaScript, but everything that I write in the series will be completely regular JavaScript. Next, we need a rendering context, usually called GL. This rendering context variable is so ubiquitous that it's almost impossible not to know what it is and why it's important. Most directly, it's the interface that we use to issue all of our WebGL commands. It contains all of the functions we use to create WebGL state, manipulate its contents, and render things to the canvas. In a word, it is WebGL. What's maybe easier to miss is that you can have multiple rendering contexts. If you want to render to two canvases, you must have two rendering contexts, two GLs. But we're only going to have one canvas in this series, so let's not do anything fancy. Currently, WebGL contexts come in two versions: regular WebGL and WebGL2. Obviously, WebGL is the rendering context we used in the previous version of WebGL. WebGL2 is the latest version, and it provides a whole bunch of new functions, optimizations, and speed improvements. Of course, this is the version that we're going to be using in this series. How do we get a rendering context? Naturally, we get it from the HTML canvas element itself. We're targeting WebGL2, so we specify that here. Last, we need a WebGL program. We're not going to do this here, but all the code that we're about to write really belongs in its own function. That's because most WebGL applications will have more than one WebGL program. But I want our code in this series to be as simple and linear as possible, so this won't be tied away into its own function. GL program is how you switch between WebGL programs, and even if you only have one program, you won't be able to do anything with it until you call this function. So we have a program, but we see here that it's not valid. To create a valid WebGL program, we need linked compiled shaders. Here are the general steps that you'll always follow. You'll notice that the process is identical for vertex shaders and fragment shaders. First, we create a shader object, then we set its GLSL source code, then we compile the shader, then we attach it to the program. When both shaders are attached, the final step is to link the program. If all went well, the invalid program we began with is now valid and ready to work. So let's create our first shader. It's a vertex shader. We'll add some GLSL source code, and compile it, and attach it. The GLSL source code doesn't exist yet, so let's create that. Because we're using GLSL 3, the very first line must contain this version directive, or nothing will work. Also, I'm using a VS Code extension called GLSL lint, which shows errors in my IDE, and this line enables it in my code. Now, our incredibly simple program. It's just a single point in the center of the canvas. Great, now the fragment shader. Our GLSL code is going to be just as simple. We'll just output the color red. So this isn't working. Now, I know what the problem is. In fact, GLSL lint is warning of an error right now, but it would probably be a good idea to get more debug info than just this. If you want to do this properly, I recommend that you check out how a WebGL library like Twiddle.js does this. Okay, so even though we got that error, let's try to link the program. Whenever linking fails, the program parameter link status will be false. And if it's false, you can check the shader logs for any warnings and errors. Checking the log is expensive, so we don't want to do this unless we have to, unless there's an error. Okay, so there's a lot wrong here. WebGL doesn't seem to like my fragment directive very much, but that's just a warning. That's okay during development. Really, the problem we're seeing here is in our fragment shader. In GLSL1, we used to set the output color of our fragment shaders using the built-in variable glFragColor. But we're using GLSL3, and in this version, glFragColor doesn't exist anymore. Instead, you must declare a vec4 output, and you can name it almost anything you want. And that still doesn't fix it, but this time we see there's a precision error. That's an easy fix. If you're not sure what this error means, I have another video explaining precision I recommend that you check out. So now, let's draw our point. This seems strange to use draw arrays when you have no vertex data, but that's okay. What we're doing here is completely legal, if a bit useless. We are drawing a point to a static location, and we're drawing it only once. Success, except no point. This code is correct, but there's nothing on the canvas. The problem here is that we have an incredibly small point. Let's give it a decent size. Okay, now it's working. Not very useful, but this will work fine as a starting point for all of the videos to come. Let's take a quick detour for a moment to talk about precision. I was pretty confused by this when I first started writing shaders, not that the concept was difficult to understand. Your choice of precision basically defines where you want to draw the line between performance and numerical accuracy. At its worst, it's a choice between either high frame rates but potentially buggy renderings, or correct renderings but sluggish performance. Offering precision as a choice to developers exists in compiled languages like C and C++, where you can choose between a float and a double, for example. Choosing data types often has more to do with memory usage, but it also has a performance impact. It also shows up indirectly in JavaScript. Here, numbers in your programs are by definition double precision 64-bit values, but internally, in Chrome's V8 or Firefox's SpiderMonkey, numbers often initially exist as 16-bit integers. For example, you could profile these three loops. You can expect the first loop to execute quite a bit faster than the second or third, simply because the lower precision allows optimizations that result in faster execution. So this was not the confusing part. What got me was all about where you had to specify precision for your shaders to compile at all. And the quick answer? For the vast majority of programs, you only need to specify precision in fragment shaders and only for floats. The long answer? Basically, except for booleans, every variable that you declare must come with a precision qualifier. But certain data types come with default qualifiers, that is, qualifiers that are pre-declared and globally scoped. For these data types, you can omit a precision level if the default level is already adequate for you. And what are these data types? In vertex shaders, they are floats, ints, sampler 2Ds, and sampler cubes. In fragment shaders, they are ints, sampler 2Ds, and sampler cubes only, no floats. So if you want to declare a float in your fragment shaders, you must supply a precision or your shader won't compile. Same goes for vectors and matrices because basically they're composed of floats. So this compiles, but this doesn't. Still doesn't. And it still doesn't. But now it does. Floats aren't the only data types affected. If you use any of these sampler types in either your fragment shader or your vertex shader, you must either specify precision for that variable or a default precision for that individual data type. Now, what should you use for your floats? Currently, the overwhelming consensus is to specify default medium precision for fragment floats. But remember, that's a choice, and it's something that you can change later based on performance feedback. There's actually a lot more to explore on this, but for me, that's about all this deserves. In this video, we're looking at uniforms. We'll look at what they are. We'll start to make some sense of uniform locations. This is applicable to attributes as well. We'll write some basic code that uses uniforms for simple values, and we'll look at some slightly more advanced usage, where we use uniforms to send arrays of values into our shaders. This last one is such an important part of WebGL, but it's often overlooked, especially in beginner tutorials. Okay, so uniforms simply are global variables that we can define in our shaders and set in our JavaScript. Vertex shaders and fragment shaders can have their own uniforms and can share the same uniforms. During a draw call, this value remains constant for your shaders. If you want to change a uniform value, for example, if half of your objects are green and the rest are red and that color is set in a single uniform, you can only do it in a separate draw call. That's not a bad thing, but if you have dozens or hundreds of objects, each with a unique color, uniforms are not a great choice. You'll definitely want to use attributes, since they can do this in a single draw call. Next, we need to talk about locations. Uniform locations and attribute locations are both values that help connect your JavaScript, which executes on your CPU, to your compiled WebGL program, which executes on your GPU. In JavaScript, we tend to think of looking up an object property by its string name as being easy and mostly inexpensive. But in a compiled language, property names are mainly a convenience for programmers. And during compilation, they're almost always replaced by pointers or offsets, or in other words, by numbers. And what these numbers are in a program after it's been compiled is usually not guaranteed. So if names are out and numbers are unpredictable, what do? Well, you ask the program. You ask, hey, GPU, where did you put u_foo in this program? And the answer back is something like, it's the third uniform. That's what get uniform location and get attrib location is all about. Okay, so hang on a second. Why does get attrib location return a number, but get uniform location return an object? A WebGL uniform location object, an object that has no properties and no constructor. I'm sure there's a reason, but honestly I don't know. But in the version of OpenGL that WebGL is based on, GL get uniform location definitely returns an integer. So that location object seems to be an opaque wrapper for that number. Anyway, it's best to see it as a number and not to think about it too much. So since the WebGL program won't change once it's been compiled, this value won't change either. So you only need to ask for it once per WebGL program after you've compiled and linked its shaders. You definitely don't want to ask for a location for every animation frame or for every draw call. You're going to get back the same value again and again. Let's see what this looks like in a fragment shader, for example. First, we declare a uniform of the appropriate type and give it a name. Then we use that variable wherever we need it. And then in our JavaScript, we ask the GPU for the location of this uniform and keep track of this value for when we need to use it again. Then we call the appropriate setter using our location and the value or values that we want to be used. And honestly, that's it. It's one of the simplest parts of WebGL. Let's see this in action. We're going to go back to our Hello World program that we made in an earlier video. What I think we'll do here is change the vertex shader. Let's set the point size and the position using uniforms. So we'll need one uniform for the point size and another for the position. In fact, why don't we make the position uniform a vec2, just pass in an x and a y. GL position still needs a vec4, so we'll need to add the remaining information statically. Now the JavaScript. Let's get the uniform locations for both. And pass in some values. And that works. Let's try a couple draw calls now. Perfect. One thing to note is that the data type that you choose in your shader determines which function you use to set the uniform's values in your JavaScript. For example, if your shader expects a uniform to be a vec4, you need to use uniform4f. If it expects an int, you need to use uniform1i. This summary shows some shader data types and their corresponding WebGL setters. It's pretty intuitive. But wait, I hear you shouting, what about the v? Almost every function for setting a uniform has two versions. For example, there's both a uniform4f and a uniform4fv. What's with that? Great question. If you choose the v methods, instead of passing in 1 or 2 or 3 or 4 value arguments, you pass in an array of values instead. So these first two statements have the same effect. It's almost as if these are functionally identical and interchangeable. And in this case, it's true. But if the non-v variants are for setting a single vector, the v variants are actually for setting arrays of vectors. In the third statement here, we're effectively defining an array of 3 vec4s. The first vec4 is 1, 2, 3, 4. The last vec4 is 9, 10, 11, 12. And this is incredibly powerful. Consider this JavaScript. In the last line here, we're picking a color from a list of RGBA colors. Since index equals 0, we're selecting the first color from the list, which here appears to be red. And we can do the same thing in our WebGL programs. First, we need to define some uniforms, one for the color index and the other for an array of 3 vec4s. If you're unfamiliar with C-style arrays, the square bracket notation here is how you define and initialize a fixed array of a certain data type. So we're defining uColors as containing 3 vec4s. We can then select one of these colors with our index and assign it to fryColor. And then in our JavaScript, we set the uniform values like before, except this time we pass in an array of 12 numbers to the colors uniform. Let's try this out in our application. First, let's clean up a little bit. Instead of our static vec4, let's pick a value from a list of colors. Our index uniform is an int, and our RGBA colors will be vec4s. And there'll be 3 of them, and that's all we need. Just remember what you call them. In our JavaScript, let's look up our uniform locations. The index is an integer, so we'll need to use uniform1i to set it. And let's choose the first value from the list, that's 0. And for our colors, we need to use uniform4fv. We have to pass in enough numbers to create 3 vec4s, so that's 12 numbers in total. Fewer will cause an error, and more will simply get truncated. We got our red point back, but is it working? Yes, it is. So that's the uniforms crash course that I really wish I got when I first started learning WebGL. I really hope this helps. After shaders, attributes are probably the single most important part of WebGL, so giving attributes the attention they deserve in this series is going to take more than one video. Here, we're going to look at some of the basics of attributes. We'll see some of the things that are new in WebGL 2. We'll look at attribute locations, including 2 syntax options that I recommend that you try out, including one that's new to WebGL 2.
I think I'll continue to watch this off stream. And so that's 1 hour or more here. Yeah, the thing about this is that they don't say anything about the position. So, like, it's just explaining the language, but maybe in the other videos they're gonna talk about. But it doesn't help that much to understand what is actually going on the concept level. Field of view. It's here. I didn't see it. Yeah, now I'm questioning whether or not I should, instead of making view matrix here, I should create an object that has these properties here. I think that's probably better because it's not only the view matrix, it's all of this stuff that I have to change every time, I think. So in here, it changes only these properties because it should be. So it only has scale and translation. But the other one, I think it would be better if I had the view, the projection, and inverse projection as key value pairs here. Each one is a class. The value. But then that's the... Okay, it's tricky, I have to understand more because of... I think the translation is done inside of the view matrix. The other option is obviously to put this stuff inside of the view matrix as well, view matrix class. But I'm not sure if that makes sense or not. I think it doesn't because it's not the same thing. So it's better to keep them separately like he did here. But if I keep them separately, so maybe like I should create the view should be like it should be the exact same way that it is here, but instead of these properties I would have all of these properties here as keys, and then the values would be the same as the ones that are here for the thing. I think that's the way that makes the most sense in my mind right now. So field of view is probably like a projection. It seems like it is a circle. As if you were watching like a movie from the projector. The field of view would be the array of photons or light that creates the movie. I think that's the way that it works. Just like the angle you have, I think. The model matrix represents the position, rotation, and scaling of the objects in the scene. Position, rotation, and scaling of the objects. Huh. So I think that's the thing. So I should have the view and the model, and then I should separate into these two classes and replace the scale and translation here. The translation would be the view, and then the scale would be the model. But obviously it would be just model and view, the name, because there's more stuff. There's the position, rotation. Typical usage of projection matrix in WebGL is to combine it with the view matrix and model matrix to transform 3D vertices from model space to screen space. So I think I need the three. Projection, view, and model. And then I create a class for the model, and the projection is just this variable, this matrix. And so I'll have to think about how I'm gonna change this, how I'm gonna calculate everything to update the values on all of these functions here. So just trying to clarify more, like what is gonna be, trying to gain more clarity in my mind over how the image is created with WebGL. So I can then understand the difference here in these calculations that is doing to get the camera and set the camera. It's on the other file. I'm struggling to think about how I'm gonna change the thing. Like, it's hard because there are multiple different, like, the other one has different files, so I'm trying to, at the same time, trying to understand how this stuff works. I'm trying to understand how all the files are related to the, like, the view matrix here. The view would be an object that has the view matrix and the model and the other stuff. That's the problem. Because I don't know all of the elements that are necessary to create the camera state. And here is obviously just width and height, and then the scale that is updating. And the position is based on the width and height and pixel ratio. It looks like the OBS disconnected. I forgot to quit Discord. But here is really difficult because there's all this other stuff, which is this sphere things. The field of view that I don't understand really well. Like, the picture that I have in my mind is a projector. That's what I'm thinking about. I think it's similar to the stuff that is going on here, where you have the field of view, which would be the size of the projection, the angle of the projection. Then you have the projection, which is the stuff that is showing up on the scene. And then the inverse of the projection would be translating the coordinates back to what they would be if they were actually not, like, being projected. But I'm not really sure if that makes sense or not. And also trying to understand how these files are related. Like, how can I break down the files and reconstruct in a way that is gonna work there with the way that VGS is. Because I don't wanna remove things or do stuff that is gonna break the whole thing down. That's the problem. Yeah, the question I think is, do I put the stuff on the inside of this view matrix class? Do I put the model matrix here as well? In order to have the scale? Or do I make it on the top level and then I create the object there and make the view and the model? And in that way I would change the camera state based on the view and change the scale based on the model. But they will both be part of the view on the main thing, in the body there. And this dot body dot view. Okay, but does it make sense to separate the scale from the model matrix? Graphics and the WebGL, the view matrix, the model matrix are transformation matrices that are used to position and orient objects in the 3D scene relative to the camera's viewpoint. The view matrix, also known as the camera matrix, represents the position and orientation of the camera in the scene. It transforms the world coordinates of objects into camera coordinates. What does it mean by world coordinates? Where the camera is located at the origin of the coordinate system and looks along the negative z-axis. Origin of the coordinate system. The view matrix can be thought of as moving the entire scene in the opposite direction of the camera's position and orientation. Effectively making the camera appear stationary while objects in the scene move and rotate. The model matrix, on the other hand, represents the position, rotation, and scaling of an individual object in the scene. It transforms the object's local coordinates into world coordinates, which are relative to the global coordinate system of the scene. The model matrix is used to position, rotate, and scale objects in the scene according to their desired transformation. The relationship between the view matrix and model matrix is that the view matrix is typically used to transform the entire scene, including the camera and all objects, while the model matrix is used to transform individual objects within the scene. So the model is for the objects. So I think here he called elements. That's the model matrix on this one. And the scene root is an element, and the other ones are going to be elements as well. The point and line, line collection. Oh, where did I saw that? Maybe it was on create scene, create graph scene. Yeah, here, scene append child. And this scene is gonna be the root scene. Appends lines and nodes. So scene is the create scene, which is this thing here, which passes the canvas. But here it doesn't have append child. Or it does. Yeah, scene root, append child. That's the thing. So it's creating the scene root as an element, so the element would be the model matrix, I think. And the view matrix is the main thing. So I think it does make sense to just leave it like this, because when it's updating the camera state here, it doesn't say anything about the objects in the thing. But maybe it should, but yeah, here, like, if it was necessary, there would be stuff related to the nodes and edges here, I think. So I think it makes sense to leave it like that, where I just put the view matrix there, and then I just... Yeah, I think I'm gonna ask if it makes sense to put scale on the view matrix, because that's the only thing that is missing. It has position, orientation, previous height and width, let's say. I think the previous height and width is gonna be different because it's like the coordinates here are represented through the position. And the center, so I think that it does make sense to just leave it as the view matrix there. And here it's probably gonna deal, yeah, it deals probably with the objects in the canvas renderer thing. So it's fundamentally, like, it's the same thing, but then on the canvas renderer, I'm gonna use the other elements instead. But the thing is that the scene should be an element as well. So I think the canvas should be on the other project. It should extend the elements class, I think. Yeah, canvas extends the element class because it has to be the root element. So this is gonna be like a model as well. Remember, change the name from element to model. One thing that I can do is put the code there on ChatGPT to see if it thinks that the element file is a model or not, model matrix. And there's a lot to think about, so Yeah, I think this makes sense. So it is exactly the camera state is the view matrix, and then on the file there on the canvas on those functions, I'm gonna update the view matrix based on that. So I'm probably gonna have to put like first I need to understand more how these functions work, why the calculations are the way that they are. But I think that this is pretty similar to the stuff that is happening there. Because this canvas rectangle would be like the canvas width and height here. So it's pretty much the same thing, I think, that is happening. But here's getting the rectangle as an argument. I think it doesn't use this anywhere on the create graph thing, but I don't remember really well. And the weird thing is that these ones are kind of mixed between these two files here. The functionality there, so I don't know which one is like the one that is closer to the one that in VGS. But I think this one seems to be closer to the one in VGS. There's so many things that I want to ask as well, ChatGPT, to understand more. It's gonna take a lot of time. Not sure if I'm gonna be able to do this, like transform everything until the point I might have to do like a simple visualization, like a static one, just to deploy everything, because it might be very difficult to deploy as well with Svelte and Flask. Figure out a way to deploy. I don't know how it's gonna be. And I also have to create extra functions to trigger the graph when you click the button. But I think that shouldn't be that hard. You just send just make an API call when you click the button. And then it triggers the function and sends the data through the WebSocket. But it might be annoying to, yeah, like figure out like how to set up the WebSockets in the deployment thing. Yeah. Like if I have to see if I can start the front end without the, I think I can, and then, this is not that hard to see, I think. But to translate everything here, I think is gonna be very hard. It might take a lot of time. Based on how difficult it is already to understand this. But it might be one of those things where initially it's very hard because I don't know. I don't understand really well how everything works. But then the more I look into it, the easier it's gonna be to translate everything else. Because I'm already gonna understand the concepts. But I think that the physics engine is gonna be very hard. Because that's where all the calculations happen, so it might take like a lot more time. Yeah, that's the model matrix here, probably. Model view projection. So I think I'm starting to understand how it works. So the create scene has the functions that are similar to the canvas there to create. And then the view should be the view matrix, I think, the parent one. And then inside of the canvas class on this one, I should update that function so that it changes the values inside of the view matrix accordingly, in the same way that the canvas does. Just gonna ask ChatGPT about the scale on the view matrix, because it didn't have the scale there. So I'm not sure if it makes sense or not. When updating the camera state in WebGL, the process is similar to the normal canvas context in terms of updating the view matrix. The view matrix is typically updated based on the position and orientation of the camera, such as its position in 3D space and the direction it is facing. The difference in WebGL is that the view matrix is usually calculated using a math library specifically designed for WebGL, such as GL matrix or WebGL math, which provides optimized matrix operations for use in the GPU accelerated WebGL rendering pipeline. The model matrix, on the other hand, is typically updated for each individual object in the scene based on its desired transformations, such as its positions, rotation, and scaling. The specifics of how the model matrix is updated depend on the application and the desired behavior of the objects in the scene. In WebGL, the model matrix is also typically calculated using a math library optimized for use in the WebGL rendering pipeline. In terms of updating based on the width and height of the canvas, the difference between normal canvas context and WebGL is that in WebGL, the rendering is typically done using a perspective projection matrix. Okay, so yeah, that's the thing. So instead of making based on the thing, I'm gonna have to change the values based on the projection that exists on the view here. Or maybe on the other file, on the create scene file. Yeah, now I don't know if I should put the functions, the value there inside of the view matrix, the projection. So I think I'm gonna ask ChatGPT. Because what I have to do is, instead of updating the values here based on the canvas width and height, I have to update based on the projection. So maybe what I have to do actually is create another variable inside of this canvas class. That will be the projection. Instead of making the camera state like the way that it is here. Should be the object. I put the values that the create scene class has. I think that makes more sense. So I would make these values inside of the canvas class. And then instead of updating canvas state, I'll update the projection based on the... Oh, let me think. Don't understand why this is not equal to anything. Like it's just calling on this thing here. This is the stuff that ChatGPT was talking about, the MVP before. This stuff here. Getting the matrix, the model and the view and combining them. So it's updating the model based on the projection to get the coordinates. Yeah, so I can create a variable called position on the canvas class, and then I'll update that instead of updating the camera state. I think that's what makes the most sense. So this file here is very similar to the canvas file, but there are additional functions here that I can move to somewhere else. And I think I should extend the class instead of making the scene root like he's doing here, because on the other project, on the VGS, it's probably different. I'll have to see how the nodes and the edges are gonna be connected to the canvas. So this class here is probably similar to the create map controls here, I think. That's probably what is going on. So the create scene is, I think I'm gonna comment this. Maybe I'll comment on this one. So here, I should delete this. So I think I'm gonna try to incorporate on the canvas here. The functions, I'm gonna change this one so that instead of using camera states, I use the values that I have here. These values here. And then I can change the functions here to update these values instead of updating the camera state. And this one is gonna use the view from the body, from the network. Just gonna use the view matrix from here. The only thing that I'm not sure is the relationship between the model, which is the element, and this one. So maybe I should do it like this. So the canvas is here, set of components. Yeah. So I think I should do like this instead, because outside of this class, when he's using the canvas, it's probably gonna, on the other methods, it's gonna update the canvas with the other things directly, so I don't have to create another variable inside of this one and manipulate that variable in the same way that it is here with the scene root. But I think I want to try to make it as close as possible. Like, try to change the least amount of things as possible, so that is easier to see if it's gonna work or not in the end. And it takes a lot of time because I don't understand how it works really well. So there's nothing like I can do about it. I think trying to implement things faster is gonna be worse in the end, because then I'm gonna have a bunch of stuff and I'm not gonna understand how everything is connected. It's much better to try to understand how the calculations are happening here to see if it makes sense or not, like how to do it so that I update the values in the correct way. And these things here, I think that I should put these methods inside of the create function in the canvas. This is the first function that is going to be called in the network. So after here, I put this stuff here. I think I'm going to put it here. And instead of gel is obviously the thing there. I think this makes sense. Oh, it's this, not this frame, this canvas. And then the rest of the stuff I put in the beginning of the class there. These things I think I don't need because the event listeners, I'm going to do it in a different way. Frame token, I'm not really sure what is the point. Pixel ratio, it already has here. Maybe I'll open this on the side. Add these things here. I think I don't need to put this because it is here probably. So on this one it uses from the options instead of putting it as variables here. I also think I'm not gonna do this thing here just because it's different than this. but I think these other ones I should just copy there and put here. Maybe after the options so I can... I'm probably not gonna use the camera state. And this here, I'm not sure if that makes sense or not. I think it doesn't, because this is probably already encapsulated into the class, into this class here. Because that's the difference between the two, is that this one is more related, like is more general than this one. So the levels are different, that's why it's confusing. Because here there are gonna be functions as well that render the frames and things like that, but I think those functions are in the canvas renderer in this one. So it's in a different class. So I need to put only some of the stuff on this one and then just see the functions that are similar, and then when I look into the other class I try to translate the other class. It is kind of confusing. So I think that's everything that I had to put on this one. And now I just have to change the function so that I update these values, and I'm gonna look at these functions here to try to understand what is the correct way to update the values there. There's also these functions about color, but I think I'm gonna... the thing is, when I look into the other classes, I might go back into this one and then add the functions here, so I can update from the other classes these values here. But I don't think that makes sense to do that now, because first I have to change this one, and then only when I see how this updates the colors, then I'll go back. I think I'm gonna stop here, and I'm gonna take a break, and probably come back in a few hours to spend another 2 hours today, or something like that. And I think I'm gonna watch the videos off stream here on this, and also maybe ask ChatGPT more questions, try to understand. I think what I'm gonna do is copy the functions for both classes, the functions that I think are similar, and I'm gonna ask ChatGPT how to convert the functions from this one into updating the values on this one. But I have to understand more how the values that I have on this create scene here are gonna create the scene. And all these calculations here, so maybe I'll ask ChatGPT as well, line by line here, to explain. I think that's a good idea. But I'm gonna stop here, I'm gonna take a break maybe in a few hours to come back. Then if I don't come back today, I think I'm gonna try to come back tomorrow, but then maybe just Friday. And I'm gonna work on this off stream, obviously. And I think if until Friday I can't, if until Saturday I can't change everything, do the class like update VGS so that it uses WebGL, like do the whole process, then I'm just gonna go back from the scratch there, and I'm gonna do like the simple visualization that I was doing before, which is just static, and then just add the most basic stuff and deploy, and try to deploy to get a link just to send the update to Buildspace. But obviously the goal is just to, I'm gonna figure out eventually. Might take a long time, but I think I'm gonna figure out. And then the goal is to use everything, get all the functionality from VGS, but use WebGL instead because it's faster. And then only once I have that, then I can start thinking about all of the different ways and different things I can implement to make the visualizations useful. So yeah, there's a lot of work still.